Welcome, everyone. Thanks for joining us today. Axiom hosts a quarterly webinar on how data is being used to transform commercial refrigeration. This is our Q4 2023 installation of the webinar. So highlighting a few housekeeping items before we get started. As attendees, your camera will be turned off and everyone will be muted. If you have questions during the presentation, please use the Q&A tab at the bottom of your Zoom screen, and you can enter questions there. We're going to reserve, the goal is around 8 minutes for Q&A at the end here, potentially more, potentially less. And we're going to address questions at that time. So we're looking forward to having a conversation with the folks who are attending today. And we are recording today's presentation. We're going to make it available when it's ready, hopefully by next week, holidays allowing. And if you see or hear something from our panelists today that you'd like to learn more about, feel free to send us an email and we can set up a one-on-one call to discuss more. And that's not just for Axiom, that's for any of the panelists on as part of today's discussions. So a really key tenet of these quarterly webinars is that this is not a sales pitch for any of the organizations that we're representing today, that the panelists represent today. Instead, this is an opportunity to have an industry conversation about a highly relevant and urgent and timely topic, the recent EPA ruling that was released in October. Instead of being a sales pitch, this webinar is meant to start an industry conversation. So ideally, retailers and suppliers will learn from our panelists' experiences with refrigerant leak detection, repair, avoidance, and programmatic management. Our goal is to help participants evaluate ways to improve their own refrigerant leak rates. If you only take one thing away from today's discussion, it should be that there's no silver bullet that works for everyone. Many of the leak detection methods we're going to discuss today are complementary, and minimizing refrigerant leak rates requires ongoing attention and vigilance. So I'll get off my soapbox here. Let's start with some quick intros. I guess I will get back on. I'm Amrit. I'm the CEO and co-founder of Axiom Cloud. I've been helping grocery chains and large commercial refrigerated facilities optimize their refrigeration for over a decade now. Refrigeration is a massive climate opportunity and a huge overlooked financial opportunity. We started Axiom Cloud a few years ago to solve the biggest problems plaguing this space using software and automation. And today we're really going to focus on our early leak detection module. And yeah, that's operating in hundreds of sites today. I'm really excited about what we're doing with this module specifically because we estimate that it multiplies Axiom Cloud's total climate impact by a factor of 11. So we're very, very excited about this opportunity to help the industry in this particular way. So with that, let's go on to our second panelist, Joe with MSA Backrack.
Hey, thanks, Amrit. Good morning or good afternoon, depending on where you're at today. My name is Joe Arena. I'm the commercial leader for MSA Backrack. MSA bought Backrack in 2021, which added over 30 years experience in refrigerant solutions to their already broad safety portfolio at MSA. And our mission is to provide comprehensive solutions that help our industry partners reduce costs, improve efficiencies, and ultimately attain their sustainability goals, all while enhancing safety and protecting their assets. And as Amrit mentioned, this is a critical time for the industry. A lot going on, I think, especially after January 1st. We fully expect to be part of that solution and appreciate the opportunity to be part of the dialogue today. Again, over 30 years experience helping customers and partners reduce their leak rates. And look forward to the dialogue and answering any questions that come down the pike. Thanks.
Man, I was proud of my 10 years, but Joe blew me out of the water. Michael, you're up next.
Good morning. I'm Michael May. I'm president and co-founder of Effectera. Effectera was founded 3 years ago, basically to help people with the technology transitions that are required to enable the climate solution that we are all working towards. Very good to be here. I'm happy to discuss refrigerant leakage. At the end of the day, we believe it is the one problem that must be solved for us all to achieve the climate solution we're trying to enable. Thank you.
And we'll talk about some refrigerant lifecycle management stuff too later on. But next up, Fritz.
Yeah, thanks, Amrit, and thanks for having me today, this morning. Appreciate it. I'm Fritz Troller. I'm the CEO of Therm. Therm also, as Effectera is about 3 years old, we're the leading developer and marketer of refrigerate RCCs, which are refrigerant carbon credits in the marketplace. And thanks again for having me.
And finally, Danielle.
Danielle Wright. I'm the Executive Director of the North American Sustainable Refrigeration Council. NASRC was formed back in 2015 with the goal of overcoming the barriers to the adoption of natural refrigerants, CO2, propane, ammonia in supermarket refrigeration. We do that with the help of all of our members, all of whom the panelists today are member organizations. So, everything we do is with the support of the supermarket community. And reducing leaks is important not just for HFC systems and managing emissions, but also for optimizing and ensuring the performance of natural systems. Mainly I'm thinking about CO2. So happy to be on the panel today and looking forward to the discussion.
Thanks, all. All right, so now we're going to move through these slides pretty darn quickly to make sure that we have enough time for Q&A at the end. So with that, let's talk about just laying the groundwork here. Why are leak reductions so important for grocery and cold storage? So there's upsides and there's downsides associated with leaks. There's carrots and sticks. On the carrot side, there's massive environmental benefits. If you look at the total emissions from a grocery chain or a cold storage facility, typically reducing leaks is their #1 opportunity. Massive financial benefits. As everyone here knows, leaks are skyrocketing in cost, and that trend is not expected to slow down. In fact, it's expected to speed up. On the stick side, do nothing is no longer an option. EPA and many states are now requiring action on this topic. It looks like that first big deadline on leak detection is going to be October of next year. Not yet finalized, but that's very likely. And then this is necessary to achieve our climate goals. The bottom line here is that there isn't really a backup option. All these other great things that we're doing for the climate, if we continue just dumping massive amounts of refrigerant into the atmosphere, we're not going to hit our greenhouse gas goals. It's as simple as that. So this is something that needs to happen for a variety of reasons. So today's agenda, we're going to talk about the AIM Act. We're going to talk about what happened in October, just a couple months ago, which was the most recent draft ruling. And then we're going to dive into today's key topic, which is new automatic leak detection and leak inspection requirements. From there, we'll talk about the panelist organizations. We'll give 1 or 2 slides for each panelist and dive into Q&A. So let's start off by talking about the AIM Act. Danielle, do you want to do this one?
Sure. So the American Innovation and Manufacturing Act, which was, a lot of people don't know, is one of the last items to go across the Trump administration's desk and get sign off. Really important thing about the AIM Act is that it had bipartisan and continues to have very strong bipartisan support. So when people speculate about the future of the AIM Act and whether or not a different political administration would do away with it, you can rest assured that it's here to stay. And not only that, is the main provision in the AIM Act, which I'll go over in a second, the phase down of HFCs. That schedule is also backed up or locked into place by the Kigali Amendment, which was an international treaty that we also signed. So the AIM Act came first, but the backstop is the Kigali Amendment. So it is here to stay. And when you look at the reasons why it has bipartisan support, there's a lot of really good arguments for this act, bringing about American jobs, reducing the trade deficit. Really, it is investing in American manufacturing and bringing a lot of that investment back to the states where it was previously abroad. It also ensures that the United States stays competitive in the world market, because guess what? Everyone else is also phasing down HFCs and has been for some time. So we're a little bit behind with compared to Europe and even Asia to a certain extent. So there's 3 authorities that the AIM Act gives to the EPA. The first is to reduce the supply of HFCs by 8 to 85% of baseline by 2036. So that's the phase down that we're going through, and a big milestone starting next year in 2024. A lot of questions about the impacts that's going to have on refrigerant supply and prices. When we look to Europe and a similar phase down step that they took back in 2018, that's when we saw the sharpest price increases, up to 900%. So TBD when we get to next year. The other authority that the EPA has is to restrict the use of HFCs, and this is done through the technology transition rule that was finalized back in October. And this, depending on your sector, restricts the use of HFCs, or the sort of maximum GWP number that you can use. And then finally, the draft rulemaking that we're talking about today, where comments were due yesterday, minimizes the release of refrigerant HFCs and maximizes reclamation. So really a lot of different things I know we'll talk through with this rulemaking, and it's controversial. I don't think I've talked to anybody who's happy about the proposed rule on any side of this. So, we'll see how the proposed rule changes. I've heard also that the EPA will be motivated to finalize this rule before the election next year. And so, we'll expect to see that finalized in the fall. Really significant thing about the AIM Act that a lot of people don't know is if you look at the amount of the greenhouse gas avoided that's projected by the end of 2036, it is over 4,560 million metric tons of CO2e. And this makes it the single most effective climate action that the US has taken or will have taken at that point. So a lot resting on the AIM Act, and again, a lot of bipartisan support to see it be successful.
So Joel, can you take us through a 30-second overview of timeline for implementation of this AIM Act?
Yeah, I'd love to. Apologies, my camera is not kicking on right now. I think the important thing to add on to what Danny was just saying is that we're taking a couple of different approaches to implementation. So this is something that's already started. So if you look at 2020, that's when we started the banning the production and import of the HCFCs like R22. What you're going to see next are a couple of series of steps where in new equipment, you're going to be banning the use of those HFCs. So in 2025, it's going to be standalone, medium, and low temperature commercial equipment. 2027, you're going to see commercialized refrigeration systems banning the use of these, high GWP HFCs. The really important thing here, and as Danny alluded to this, is that we also have to do a phase down of the existing systems. And so the goal is by 2036 to have that reduced by 85%. Amrit, do you want to click to the next one?
Yep.
Great. Yeah, and so the biggest change is really coming up next week. Or how many days do we have? 13, 14 days now? 13 days, right? Where we're going to see a massive reduction in the phase down. So we've been operating at 90% of the baseline that was established by the EPA. That's going to get reduced to about 60% here starting January 1, 2024. With another significant step down coming in 2029. So when you're thinking of all the systems that are out there, you're going to have to start figuring out replacements as those go. As Danny mentioned, we're also expecting probably some big spikes as far as the pricing of refrigerant according to these different step downs. So it's going to be very, very significant, and it's happening very, very soon.
Yep. And Danielle, you were alluding to some of the big price spikes that happened in Europe in a very similar phase down situation. That we might see something similar here. Thanks, Joel. All right, so let's talk about what happened in October. So there was a draft ruling released on October 6th. There's 300 pages long. It's currently a proposed rule, so it's not yet finalized. The comment period ended yesterday, December 18th. And the topics covered included repairs, leak inspections, use of automatic leak detection, reclamation, really importantly, tracking of HFC usage, which was kind of taken out of the conversation for last couple of years here for various political reasons, and some other things. Today, we're really going to zero in on, in fact, Yeah, it might be. Joel, would you mind dropping this into the chat for participants, just that one pager from the EPA that kind of talks about subsection H?
Yep, I can do that.
Perfect. All right, today we're going to zoom in on new automatic leak detection and leak inspection requirements. And again, basically, there is going to be some sort of requirement to install these ALD systems as written. It looks like it's going to be October 2024. That is still subject to change, but the key message here is that this is coming really, really fast. And so you're going to be, as an operator of large commercial or industrial process refrigeration, you're going to be required to install an automatic leak detection system if you have a facility with over 1,500 pounds of HFCs. If you have a commercial refrigeration equipment with a leak rate over 20%, or if you have IPR equipment with a leak rate over 30%.
Amrit, I just want to add, it's also if you have refrigerant with higher than GWP of 53.
That's right. That's right. So, which is basically every refrigerant except for ammonia and CO2.
And propane.
And propane, sorry. Yes. That's why we have Danielle here. Perfect. And then the other kind of key piece here is that if we're installing automatic leak detection solutions that provide partial coverage, so in that case, the quarterly manual leak inspections will still be required. So for example, if we're not covering rooftop condensers, then you're still going to have to do those quarterly manual leak inspections. So let's talk about the status quo of refrigerant leaks today. Fritz, would you take this one?
Yeah, happy to, Amrit. So from a retail grocer standpoint, I think a well-publicized leak rate that the EPA put out a few years ago was a little over 25% for commercial or retail grocers. There's a wide range of different leakage rates at retail grocers. Green Chill members, obviously much lower. Our engineers have looked at a range. I looked at the range of the hundreds of different sites that we've actually worked with. And that range is from 6% on the low end to 54% on the high end in leak rates on a store basis. In cold storage, the leak rates are a little bit lower overall. And of course, ammonia and HFC typically for smaller cold storage or industrial applications is a little bit lower, but that range also in the numerous sites that we've been working with is anywhere from 5% on the low side to about 29% on the high side. And of course, the refrigerant charge in those industrial applications is much, much higher than you see in retail grocer applications.
So a single leak can be massive.
Mm-hmm.
And then
Yeah, I wanted to add one thing here. I think that the other thing I want people to understand is that these rules are intended to apply to both HVAC and refrigeration. And so even though we're focused today on refrigeration, most of the operating entities that deploy refrigerants also deploy HVAC in their refrigerant applications, and those also would be covered by subsection H. And that is not the current practice. We have, for many years, focused on leakage and let's call it leakage management, refrigerant management in refrigeration. The new aspect of subsection H that we think is very relevant for everybody to understand is this will be all refrigerant use. So it will include your HVAC assets as well. And that's something that people need to start thinking about as well.
And then Michael, in your experience, what is penetration of automatic leak detection today?
Roughly zero. I mean, there are people deploying automatic leak detection today, but as a general, if you look at the total US market as a whole, you can effectively say it is pretty close to zero.
So I would assume that some participants today might view that as a controversial statement. And so let's break that down and talk about why that is. And this really comes down to kind of gas detection versus leak detection, I think. So let's talk about non-compliant leak detection methods that are commonly used today. So how are folks detecting or identifying that leaks exist today? Perhaps the most common method is case temperature alarms. So at some point, the refrigeration system simply doesn't have enough gas to provide the cooling service that you want it to. At that point, you are in a rack outage situation. And at that point, it's too late to be proactive, and you're reacting to a big emergency because you've already lost a lot of your gas, if maybe most of it. So not good. Quarterly manual leak checks are, they're ineffective in the sense that, they're only happening every 3 months. And so a leak can fester for months. Or, Joe, do you want to speak to the transients issue?
Yeah, sure. In our experience, they can snapshot. It's like comparing a snapshot to a movie, right? So, we see leaks that sometimes are only prevalent when the system's in defrost. So just walking through literally, 5 minutes over a 3-month period is really ineffective at driving down leak rates for that reason alone.
Yep. Yeah, it's expensive too. You're getting technicians out there to walk around, and the technicians are expensive. So a lot of reasons why quarterly manual leak checks are really not the gold standard when it comes to driving down leak rates. Single point gas detectors. Joe, do you want to touch on this one as well?
Yeah, there's a lot of confusion out there. So, and I'll get into it a little bit further. I'm writing in a slide or two, but there's 2 general drivers necessitating gas or leak detection. One is safety, and the other is emissions reduction. And I think those two sometimes get confused. So we'll drill into it further, but if the leak detection is there primarily for safety, occupational exposure levels in the 800 to 1,000 ppm range, they're not going to detect leaks very quickly. They're just going to detect very large leaks, if any.
But really not the right tool for the job at hand.
Right.
And then finally, receiver level sensor alarms. So, in facilities that do have the Hansen probes or the 0 to 100% analog receiver level sensors, which is definitely not 100% of facilities. When you have that data is noisy, it's difficult to interpret, and there's a lot of false positives. And so generally, unless you have some really smart technicians or managers scrutinizing this data on a daily basis, it's ignored. And then when you're thinking about the other half or more of facilities that don't have that Hansen probe in place, it's really expensive and invasive to modify and recertify your liquid pressure vessels, your receivers. So in many cases, it's really not that practical to do. So these are the non-compliant leak detection methods that folks have probably seen out there. The EPA in this new October ruling has defined 2 categories of compliant leak detection methods, and they name those direct and indirect. So Joe, why don't you take us through the direct side, which is really where MSA BlackRock focuses today.
Sure, love to. Yeah, so the direct method, as the name implies, encompasses directly measuring the gases with sensors that leak from a leak source, right? So it's currently written, this is important to note, it's not on the slide, but again, it's covered off in a subsequent one. The standard is written around, or the current proposed rulemaking is written around the ability to resolve down to 10 ppm and the action level at 100 ppm or below. Those 2 pieces are required to be compliant, again, with the system. I think that ties back to the previous comments as well about other point sensors that may not be accurate enough. Secondarily, or maybe almost as important, is the ability to get close to the leak source. So point sensors or diffusion sensors, by their very nature, are typically mounted on the wall. So they could be 10, 15, 20 feet away from the leak source. And then you have a dilution effect that further complicates things. So again, more to come on that, on the ppm values. I'll turn it back to you to discuss the indirect method.
Perfect. Yeah, on the indirect side, EPA defines that as using predictive analytics or software to monitor the real-time operating conditions of a refrigeration system. And so Axiom is one of the 3 indirect automatic leak detection manufacturers listed by the EPA in this ruling. And when you're thinking about how this works, we can definitely get into more of this, especially during Q&A. But what this comes down to is there's already hundreds, if not thousands, of live data streams in a grocery store. And using that data in conjunction with AI models enables detection of leaks very, very proactively. So put another way, can detect leaks super quickly, regardless of location within a facility. And we'll get into more about that later. So this is the really high level. These are the 2 categories that are deemed compliant by the EPA under this new rule. in order to really focus on leak detection rather than kind of human safety from large gas emissions. So let's dive into this a little bit more, talk about pros and cons. So for leaks in enclosed spaces, Joe, you want to talk about this one?
Sure. Okay. Yeah. We're going to go through them in series or one at a time, it looks like. So,
Yeah, just one at a time.
all right. Yeah. So, yeah. So, as mentioned, leaks in most use cases can be detected most quickly with a direct system. It's critical to get close to the leak points, as well as to have a detection threshold that's low. So 10 ppm is the current written standard, but the lower the better.
Yep. And on the indirect side, unfortunately, I don't have great information about some of the other indirect providers, so I'll just speak on behalf of Axiom. Typical response time for a leak is not minutes. It's going to be measured in days. And so that's not the best solution when it comes to a big gusher in the machine room. It just simply isn't. So next up, leaks outside of enclosed spaces. On this front, indirect ALD systems can be a really great solution because essentially indirect ALD is able to detect leaks anywhere in the refrigeration system, regardless of location. And it can detect those leaks quickly in a matter of days, which is very valuable, especially for those slow leaks, that kind of parasitic leaks that just, can cause a facility to lose a lot of gas over 90 days or over 180 days, for example, if they're undetected. Joe, you want to talk about the direct side?
Yeah, so when you have a larger space or you have a higher dilution rate, again, the criticality of that low level detection comes into play. So, and as well as getting close to the leak source. So it is more challenging in a larger space with a higher dilution rate. A typical example could be in a mechanical room with fans turned on. Again, if you have the right coverage, the right system below 10 ppm is certainly more and more a requirement. And as noted, although it's not necessarily intended for outdoor use, we have had experience mounting the pickups to these products or to these systems outdoors. Again, it's tougher because you have that dilution effect, and you need to get really close to the leak sources, and you need to have a system that can get down to 1 or 2 ppm to do it.
Yep. In terms of pinpointing location, direct definitely is the best option here. And that's because, Joe, I'll speak for you here. Basically, if you have the sensor, you can tell exactly which sensor is alarming. And that's going to tell you, plus or minus 10 feet where that leak is. Tell me if you have any other thoughts here, Joe.
Yeah, and it also gives you a measure of severity, I think, as well, in terms of the ppm concentration. It's tough to correlate exactly, but obviously the larger the concentration and can sort of geolocate the leaks and pinpoint them better when you're on site.
Yep. On the indirect side, can typically locate which case group or which evaporator group a leak is located in. In some cases, a specific case or a specific evaporator. Or if in the worst case, though, we can tell you which liquid group it's on. And so we're not going to always be able to tell the location, or we will be able to tell the severity, though. Requiring new hardware and on-site installation. So Axiom, at least on the indirect side, does not require any hardware or on-site installation, can be remotely deployed in hundreds of facilities per week. Obviously, the direct side, that does require new sensors and to get installed at each facility, which need to be, of course, maintained as well as any hardware solution does. And both require calibration by the EPA. So that's kind of the same for both. Other benefits here, Joe, you want to talk about safety?
Yeah, I think it relates to the installation cost as well. So primary benefit of the direct system is that it gives you, again, if the right system installed properly, put a little caveat there, does provide safety compliance as well as a system that can drive down your emissions rates. So when you're looking at the costs associated, it's also very important to note that, hey, the safety system might cost X, and the emissions reduction system is usually equivalent to, or maybe just a small percentage more than that safety system.
Yep. On the indirect side, one thing the EPA highlights a lot is that indirect ALD systems are typically not a one-trick pony. They're also able to proactively address maintenance issues, energy savings measures, in some cases even other things as well, other ways to drive value for the facilities that are using these systems. And then finally, the EPA highlights dependence on existing controllers. Joe, you want to talk about this one?
Yeah, I mean, direct gas detection can be tied into existing controllers or can work standalone. It can work standalone to drive the emissions reduction that people are looking for, as well as drive audiovisual alarms and achieve that safety compliance as well.
Yep. On the indirect side, very reliant on the existing controllers, on the existing sensors. So if there's an old pneumatic controller or a Comtrol dial-up solution, generally not going to be a great fit for indirect. So bottom line here is that direct and indirect, again, there's no clear winner. They excel in different areas and they're often complementary. And so we'll talk about how to make decisions for your facilities, which do need to be made very, very soon here, coming up in a slide or two here. So in terms of overall best practices, if you're going to take away one thing from today, take a screenshot of this slide, basically. Do nothing, not an option. Reducing leak rates drives enormous financial and sustainability benefits. So this should be viewed as an opportunity for all the folks in this room who have known that leak rates are a problem and have not been able to do anything about it for whatever reason. Most likely, I would guess, competing priorities or competing budget priorities. Now, the EPA has given you the opportunity to put this at the very top of your list. And so I think this is a massive opportunity for all of us to really grab the bull by the horns on this super important problem. And now, there's a reason to go to the CFO and say, hey, I need dollars for this, because you've got to do it. Regulations requiring ALD are coming really fast. So you don't want to be that retailer who is, 30 days before the deadline and you don't have a solution in place and you're about to get a big EPA fine. And then you have to pay, really premium prices to get contractors out or whatever it might be. Not a great place to be. Be proactive here. And finally, direct and indirect solutions are excelling in different areas and are often really complementary. So how do you, as a facility owner, manager, make a decision about what the best options are? It's really going to be defined by your priorities. So that might be compliance, it might be GHG or ESG, safety, initial or life cycle cost, availability of carbon credits, as Fritz will talk about a little bit more, overall ROI, ease or speed of deployment, other benefits, or some combination of these things. And these are the types of questions that reach out to Joe, reach out to Axiom. We'd be happy to talk through these, and we'll be really frank, because at the end of the day, we as an industry have to outfit 20,000 facilities in the next 12 months. This is going to take a sprint. It's going to take a lot of collaboration. Everyone's going to have to really work hard in order to succeed here. And I think this is a very worthy project for all of us to be working on. I'm extremely excited about it. All right. So let's get into the final element of our agenda here, which is going through quick overviews of each of the organizations presenting today. Joe, you want to go first?
Yeah, thanks, Amrit. Just a recap on some of the topics I touched on. And I think Amrit's slide, the preceding slide, puts it very well. What are your goals and objectives that you want to achieve, right? That's going to really drive how you approach this challenge. Is safety your primary concern? Then you can specify a system that operates on the right-hand side of this chart, and you're concerned about occupational exposure levels in the 500 to 1,000 ppm range. And certainly, that's a good place to start. But if your goal is to reduce emissions, then you need to look to the left. And while ensuring, while ensuring safety compliance, you need to do both, of course. You need a system that operates reliably well below 100 ppm. And again, the lower the concentration, the better. It gives you the greatest amount of visibility, advance notice, and that crucial ability to drive down those leak rates in our experience. And I think the next slide just gives an overview of the services that we provide. So of course, we talked about the low-level leak detection, but we really have the most comprehensive offering, ranging from safety to emissions reduction, to software solutions that allow you to track your compliance to the regulations, as well as industry-leading portable products, which are crucial to then kind of find that leak, pinpoint it. Not pictured on the slide, interesting, is we also have additional products that meet other requirements of the rulemaking around reclaim. So we have products that we sell to people like the UN that checks refrigerants, looks at border crossings, and makes sure only compliant or the right refrigerant is coming in and labels aren't messed up and counterfeit refrigerant being smuggled in. So we really have a comprehensive suite of products, and we're here to help be a part of the solution, coming together as an industry. Thanks, Amrit.
Thanks, Joe. So quick overview of Axiom. So today we help hundreds of grocery stores and cold storage facilities with a lot of the challenges related to refrigeration. So, visibility, energy efficiency, predictive maintenance, early leak detection, and even demand response or overall energy flexibility. So we won't go into all the details today. Check out our website if you're interested in anything else. We're super zeroed in on the early leak detection element during today's discussion. But key takeaways: up and running in hours, payback in under a year, and portfolio-wide compatibility. Typically, payback is much, much faster than a year. But I wanted to zero in on basically a report that we pulled from one of our largest customers that summarizes 16 leaks. This is a September report from this year. It's a pretty decent representative sample, but the really cool piece here is that I just wanted to make sure that this comes across as like, this is real, this is happening. Leaks are being detected. Value is being driven to the bottom line for this customer for both a carbon accounting standpoint as well as a dollar standpoint. So, for the 16 leaks for this example customer, they ranged from 0.3 to 49.8 pounds per day. The durations were anywhere from 3 days to 289 days. And again, these are durations from when the leak started to when it was resolved. And we're only showing resolved leaks here. Ultimately, how much was lost within each one of those leaks? How many pounds of refrigerant? That ranges from a couple of pounds up to 600 pounds. And then how much was saved due to early detection? So, and the key assumption here is that essentially we're catching these before temperature alarms occur, and then estimating how much additional refrigerant would have leaked if that leak wasn't able to go to its logical conclusion of a temperature alarm. And ultimately, driving massive CO2 reductions or CO2 equivalent reductions. And this represents in gas alone about $60,000 worth of savings for this one customer in this one snapshot. So enormous financial, enormous sustainability benefits. And now you got to do it because of the EPA. So next up, let's go to Michael at Vectera.
All right, thank you. I think I would focus here on a couple of things. I think the biggest message we would give you from a Vectera standpoint is remember that the goal here is to get to zero emissions. And if you think about it in that context, zero is an absolute value and it can be measured. At the end of the day, any leak means you haven't achieved zero. So fundamentally, the issue here is you have to basically develop processes and methodologies and technology that allow you to eliminate leakage. And we think of that in the term, and you used the term earlier, Amrit, when you referenced it, refrigerant lifecycle management. What has to start happening is asset owners have to start thinking about refrigerant from the time it is charged into the equipment that they procure, all the way to the time when the equipment is retired and what happens to the refrigerants at the end of life. And on the journey between the initial charge and the end of life, they have to basically have systems and processes that enable them to basically ameliorate leakage and drive it to zero. And we think that means leak detection is one element on that journey. But as you said, there is no silver bullet. There is no single solution. You need to be deploying a whole host of technologies and methodologies if you're truly going to try to achieve zero leakage. And there are things that you should be aware of, and we're happy to basically kind of show people what technologies we believe are in development to look at helping resolve these types of issues. But as a general rule, that's what we believe is that the objective here is to get to zero leakage. which means we have to eliminate leaks, which means the whole continuum has to be involved in this process, all the way from the equipment providers, who basically have to start putting more and more effort into giving us equipment that doesn't leak, to basically systems that enable us to monitor and develop prognostics so we can predict leaks before they happen. And then into Fritz's area of, when you get to end of life, what do we do with all the refrigerant that we've basically used during the lifetime of that equipment, and how do we effectively remove it from the environment? So with that, I'll stop there.
Thanks, Michael. Yeah, Michael and his team are a bunch of really smart folks who have deep grocery and refrigeration experience, and along with all kinds of other types of experience too. Would encourage you to speak with Michael. All right, and finally, NASRC Danielle.
Yeah, so like I mentioned, when NASRC was formed, it was a group of supermarket stakeholders who saw the potential of natural refrigerants to be the ultimate future-proof solution for grocery stores. And they also saw that there was a number of barriers standing in the way of making it feasible for every grocer to adopt naturals. And so what they did is really brought that supermarket community together. Like Michael was saying, it's going to take everybody working together to solve these issues and get us to a place where we have sustainable refrigeration. And that's good for business, and that's good for the environment. So today we have over 160 members. Our food retailer members represent over 55,000 food retail locations. So I would say, we really have our secret weapon is the power of our members, and that we can leverage to, all focus together to address specific issues. And so, really our goals, first and foremost, we want to build a sustainable technician workforce, make sure there's sufficient technicians that are trained and ready to work on these systems. We want to increase funding for natural refrigerant equipment. We're doing that, in a big way in California with our contract, the F-gas reduction incentive program that will be kicking off next year. It's a $65 million program that we're hoping to expand to other states. And then, improving technology options, education and awareness. We're always trying to optimize. We have a group of retailers that meet on a monthly basis, our roundtable. And, through that process, we identified that, there are leak issues with natural refrigerant systems too. They may not have the environmental impact, but it's the same, business impact as the HFCs. And that group of retailers formed a best practices committee to focus on, what they could do to make these systems more resilient, meaning, how can we address the cause of the leaks and ensure, supply of the gas, everything to make sure that these can be good solutions. And so we are currently working on that. We'll be launching a CO2 technical committee in the start of the new year and opening up applications. If you're interested, please, sign up to receive our communications. But, overall, it's going to take, like you said, there's no silver bullet. There's many, many different options that we need to have on the table in order to get to that ultimate goal of building a sustainable future for supermarket refrigeration.
If you're not already a member, become one. It's one of the best organizations to be in this vertical.
All the cool kids are doing it.
Cool. Thanks, Danielle. And finally, sorry, Fritz. Let's talk about Therm.
Yeah, so thanks, Amrit. We are the Therm. Many of you know, many of the retail grocers and food distributors who are on know us. We are the leading developer and marketer of refrigeration carbon credits. This year, in 2023, we've issued and sold over 1.5 million tons of avoided CO2. That's a lot in our second full year of operation. And we realize, I emphasize the develop and sold portion, because our retail customers are not interested in becoming developers or sellers of carbon credits. That's our responsibility. They want to be great merchandisers and operate world-class, environmentally sensitive operations. So our role is to develop and sell those carbon credits. We have seen a significant amount of demand this past year, especially for leak detection carbon credits. It doesn't show it here, but for leak detection opportunities, our average with our customers is about $1,500 per year per store location, as it shows here, right? And that's on an average a crediting period of 7 years for leak detection. That means each store every year on average, depending on the amount of leak reduction, benefits $1,500 per year. There's also an option here to re-up that crediting period for another 7 years. So it could be a total of 14 years. And I don't have to say it. I'm sure Amrit and Joe could shake their heads at this, and that takes up a significant amount of the cost associated with installing a leak detection system. Oh, and also on these other solutions, I'd be remiss if I didn't hit the other solution sets, but I won't address them specifically. But we have a wide range of refrigeration carbon credit solutions.
So talk to Fritz if you want some free money.
Yeah, and all the cool kids are also working with Therm as well.
Great.
Is that okay, Danielle?
Yeah, you can use that.
All right. 9:48, 12:48 Eastern. We are right on schedule. So let's jump into Q&A. Thanks all for being really succinct and brief today. Joel, do you want to moderate this portion?
Yeah, I just want to invite everyone to ask their questions in the Q&A function on the Zoom tab down there. We'll try and read them off as they come in. One thing I think I want to get us started with is we've talked a lot today about the EPA, but we haven't talked about some of the other regulations that are coming into place. Danielle, we talked a little bit yesterday about some of the states are doing some other things. Do you want to touch on what some of the other states are doing and sort of how that relates to the new EPA ruling that's coming up?
Yeah, so in terms of leak detection.
Yes.
And we have a slide on this too, so perfect.
Great. Yeah, so one thing I'll say is that there was initially a big appetite, these states, majority of them, they're all in the U.S. Climate Alliance, and the goal of the U.S. Climate Alliance was to kind of backstop where the EPA was leaving off, which at the time, was EPA activity was kind of paralyzed by a lawsuit. And so what the intention of these states was to, align on their policies in the absence of federal policy. And that worked to a certain extent, because initially what the states first did was to backstop the vacated SNAP 20 and 21 rules. And once they progressed beyond that is where we started to see kind of a patchwork appear of different regulations and different motivations, different capacities to enforce those regulations. And so now what we have is really 3 states that have kind of taken the lead here on refrigerant regulation, and that's California, New York, and Washington. And so California has, not only put into place more stringent rulemakings, I guess now more stringent almost than the EPA. It's just earlier than the EPA, started in 2020, and has also put forth, a refrigerant management, aka a ban on virgin refrigerant production, SB 1206, and that in effect will require the use of reclaimed refrigerant above certain GWPs. Now, if the EPA rulemaking goes through as proposed, it would supersede or be more stringent than what California has currently put into place. So that's to be seen. California also has requirements around automatic leak detection. I believe it's above 2,000 pounds. And then Washington, which just finalized their rulemaking, will require It will set forth a GWP limit depending on the subsector at various years. For grocery, it's going to be 2025, and it'll be a maximum of 150 GWP, so very similar to California, and definitions ended up being pretty similar as well. There's a provision for existing stores to meet a 150 requirement starting, I believe it's 2029. And, we'll see. That's going to be a difficult one because retrofitting gas will trigger the 150 in that scenario. Washington also took a more stringent approach to automatic leak detection, requiring it above 1,500 pounds, just the same as EPA. New York is TBD. We expect their proposed rulemaking to come out any day now. They were hoping to get it out before the end of the year. And there again, we expect a GWP limit for new stores. For them, it's going to be 10 GWP because they're using the 20-year value. And so it'll be more stringent in that regard. And then we do expect some type of restriction on existing stores to kick into play later down the line, maybe not till 2030 or later. So we'll see when that comes out. I don't know what they're planning in terms of requiring leak detection, but, wouldn't be surprised if it was something similar, hopefully similar to Washington. Again, the original goal was not to have a patchwork of different regulations, but that's kind of where we're headed now.
Yeah, Danny, I would add one comment, and I think it's important for us all to remember. We tend to think of the AIM Act as a static document, but we should also remember that the AIM Act gave the EPA the right and the legislative authority to regulate based upon GWP potential. So because the language in the proposed rules is coming into play and will be finalized by basically this time next year, don't forget that the EPA still has the ability to modify those rules as time goes by. So the first rule set that we get is only the starting point, is the way to think about it. I don't expect the drawdown schedule to change very much from what they've published. We don't expect the technology transitions to change very much from what they've kind of set out. But the refrigerant management aspect of this, if you do the modeling, you will start to realize that we reach a period of time at the end of this decade where there is not enough refrigerant in the market to enable all the HVAC and refrigeration solutions we want to deploy. And that even includes the transition to, let's call it moderate GWP on HVAC, as well as ultra low GWP on refrigeration. So we expect that the rulemaking that we get next year from the EPA is not going to be the end point. So I think that's another thing for people to understand, is that this is all going to continue to basically head on the path to getting us to as close to zero for emissions as we can. And from what we've talked about today, the existing legacy refrigerants are the barrier to us achieving the goals we're trying to achieve. And so we expect that the EPA will have additional activity, as well as some of the states that Danny just mentioned. They will continue on a path to basically trying to regulate, let's call it moderate to high GWP HFCs for the foreseeable future.
Makes a lot of sense. Great answers. All right, what's next, Joel?
So we had a question come in around sort of the need to mitigate inspections. So I think Amrit or anyone else, could you talk a little bit about how ALD could potentially replace the need for inspections in a grocery store? Sort of where are they? What are these inspections we're replacing? Is for the cases, the cold stores, outdoor condensers? A little bit more about that.
Yep. So what completely mitigates the need for inspections for cases, walk-ins, for racks, outdoor condensers, etc.? The short version is you're going to have to go the indirect system for that to have that 100% coverage of all the systems that, of every system component. And so the specific part that I think is really important to note here is, let's see, basically EPA is proposing that leak inspections for the appliances will be required only for the portion of the appliance that are not being monitored by the ALD system. For example, if part of the appliance is not in an enclosed space. So yeah, long story short, if there are parts of the refrigeration that are not being monitored by an automatic leak detection system, you will still need those manual leak inspections. And indirect is going to be kind of the sledgehammer solution here to cover 100% of the solution and eliminate the need for those ongoing inspections.
Great, thanks. During the explanation of the direct and indirect systems, sort of went through the pros and cons and how they're different things. Are there any misconceptions we want to clear up about either direct systems or indirect systems? I think, Joe, I'll send this one to you first. Is there any sort of misconceptions about direct systems that we want to address today?
Well, I think I covered them. Is there more specifics to that, Joel? I mean, the key, again, the overarching message, if I can, leave everyone with one thought, is that the key to driving down emissions is to have a system that measures as low level as possible and can get as close to the leak source as possible. That is sort of the overarching, theme and sort of educational campaign that we're on. And I think also to clear up the confusion between a product that's meant to be purely a safety product around occupational exposure limits, being referred to as a leak detector. It's going to get even more complicated as A2Ls come into the picture as well, because there's some additional UL requirements for a flammability sensor. And our concern is that, again, these things will be confused as leak detectors. So it's another interesting aspect and twist to things to come.
All right.
Just to clarify, sorry, just to clarify, just to give a scale to that, the LFL sensors that UL is referring to is in like the 20,000 parts per million range.
It's a totally different ballgame.
Right.
We have reached the top of the hour, and I want to extend a really heartfelt thanks to Joe, Michael, Fritz, and Danielle, and Joel as well for participating and sharing expertise and perspectives on this super important and timely topic. Thanks all, and thank you for participants for being a part of this discussion as well. We look forward to supporting the industry, all of us, as we navigate these next 12 months and kind of the rush to get these systems deployed and operating in time for compliance here. So recording will be released and shared when it's available. Looking forward to continuing the conversation. Thanks, everyone.